positive values.
That's 2021. I gave it up. So let's look at this. Solving radicals. So when we're solving radical equations, the main goal is going to be to isolate and get rid of the radical. So if you want to highlight or star or do this, isolate or get rid of the radical. That is your main goal. Guys, let's focus. I don't want to talk over you. So whatever the other stuff is on the outside, you want to get rid of that first, because that's what isolate means, get the radical by itself. Once you do that, you'll be left with a basic equation to solve. And we can get rid of the square root by squaring or get rid of the cubed root by cubing. So boom. The other important thing that's almost math common sense now. I did put a warning here. Squaring both sides of your equation will sometimes create an extraneous solution. So remember, the extraneous solution will only appear if the radical's index is even. Which we're only going to really talk about square roots. So if you have an even square root, excuse me, make sure we're checking all our work. So to check the extraneous solution by substituting your solutions back into the equation. So into the non-radical side or into the radical. If it's negative, then it's extraneous, throw it out, and I'll talk about what's going on, okay? So the two big things, we're gonna isolate and then do the opposite. So if we're looking at this, this shouldn't be too crazy for you. So square root of 3x minus 5 is equal to -2. Good, my microphone's off. So what I'm going to do is I'm going to isolate the radical. So I'm going to get this by itself. So I need to move that 5 to the other side. So I'm going to add 5 to both sides. Cool. So now, change that color. Once you get this, to get rid of the square root is by itself, I'm going to square both sides. So I get 3x is equal to 9. And then from here, we can solve, we can divide both sides by 3. So x is equal to 3. All right. Anybody have any questions about that? Pretty straightforward, right? This class is pretty good with it. So now, what I'm going to do, here's my answer. So I'm going to come over here. I always want to check these if it's a square root, because you cannot take the square root of a negative number, right? With the cube root, it doesn't matter so much, but with a square root, you always want to check it. So I'm going to come over here. I'm going to plug it in. So what I mean by checking it, I got square root of 3. Anytime there's an x, I'm going to plug it in. So 3 minus 5.
Sorry, this interruption.
Yes, ma'am?
Can I have Cameron Trailer to the attendance office for a moment?
He's not here. Ruined it. All right, I'm not starting over. So let's solve it. Square root of 3 times 3. So I got square root of 9 minus 5 equals -2. So 3 minus 5 equals -2. -2 equals -2. And it checks out. Cool. I like to always plug it back in the original in case I made a mistake. Some people will tell you you can take it. Where's that duty, bro? Plug it back in. So when I solved it here, I had square root of 3x is equal to 3. Some people say plug it back into here. And you got square root of 9 is equal to 3. 3 is equal to 3. Yes, it's shorter, but I'm just a creature of habit. I always plug back into the original. But either way, I plug it back in. And you got your answer. So it works out. So x is equal to 3 here. Cool? But the only place, if you don't plug it in the original, plug it into before you take square both sides or before you cube both sides. That's the spot. All right, cube root. The radical is already isolated, so I can go ahead and cube both sides. So that's going to give me a 5x plus 2 is equal to 27. 3 times 3 is 9. 9 times 3 is 27. And now we can solve. So minus 2 from both sides. So 5x is equal to 25. And x is equal to 5. Okay. With cubed roots, you cannot have extraneous solutions. So you don't really have to do this. You don't really have to check it. If you want to, you can to make sure you did it right. You can take 5, plug it back in. So, I mean, I do have the cube root of 5.
Extraneous just means like,
It's there, but it's not.
well, that doesn't.
So let me finish this and then I'll talk about it. So I got the cube root of 25 plus 2 equals 3. Cube root of 27 equals 3. 3 equals 3. So you can always check these. That's why I like solving. You can always check to make sure you got it right. So no excuses for not getting things right. Next one's extraneous. Okay. I'll explain extraneous further here. So here I have the square root of x plus 2 is equal to x. So is the radical already isolated? Yeah, it's by itself. On the left side, all I have is the square root. So what I can do here is I can square both sides. So I got x plus 2 equals x squared. I'm going to be honest, not every time, but a lot of times when you get an x squared right here, that's when we're really going to have to check for extraneous solutions. The first one, we only had one answer. It was really straightforward. So we're not really going to usually get them there, but we might here. So now let's move everything to the left side. So I got 0 is equal to x squared minus x minus 2. Then we're pulling stuff back from last semester. How do you solve anything with the square? We factor it. So what factors of -2 give you -1? Oh, hiccups. -2 and +1. So I got x minus 2 and x plus 1. So x minus 2 equals 0 and x plus 1 equals 0. So x here is going to equal 2. And x here is going to equal -1. So I did nothing wrong. My math's fine. It factors correctly, and I got 2 solutions.
Oh, that's x equals.
This, yeah, x equals. So I got x equals 2 and x equals -1. And this is where the checking is going to become important. So if I come over here, just so I got it down, so square root of x plus 2 equals x. My first solution was x equals 2. So if I take that, plug it in, I got 2 plus 2 should equal 2. Square root of 4 equals 2. So that one's good. Because 2 does equal 2, right? And I think I can skip the square root of 4, writing it down. The second one, I got x equals -1. So if I plug that in, I got -1 plus 2 equals -1. So that'd be square root of 1 is equal to -1. So 1 does not equal -1. So this is what extraneous solutions look like. Okay. So this is not a real answer. This is extraneous. So this is my only solution that's going to work. So kind of redefining extraneous, it's a solution you get when you do everything right that just does not check back out. So it's a solution you get when you do everything correctly that just does not check out. And usually those are going to be the case when you get 2 solutions. So when you have to factor, usually you're probably going to get an extraneous solution. All right. One Josh froze, and now I got 2 Joshes. Yeah. And this is still on the recording. People are going to think I'm crazy today. All right. So this one's going to be a little bit more in depth. Just kind of walking through these. So my radical is on the right side this time. It doesn't matter. But it's already isolated. So I can go ahead and square both sides. So I have r minus 6 equals 21 minus 4r. What I did here, I strongly encourage you to do. Okay, I squared both sides. That's a little too. Square both sides to get rid of the radical. And instead of writing r minus 6 squared, I wrote it out twice. Okay? The reason I do that is because if you see it written down here, split up like this, you're going to FOIL that. If you see it written like this, a lot of people will distribute the square, which is incorrect. So anytime you got a square up there, please rewrite it twice. I promise you it'll help you out. So now when we start simplifying, if I FOIL this, I got r squared minus 6r plus 36. I'm going to go ahead and bring these over. So minus 21 plus 4r is equal to 0. So I FOILed the first part and moved everything to the left side. Now I'm going to combine like terms. So r squared is there. Minus 6 is minus 12. And then plus 4 is minus 8. 36 minus 21 is 15. And I have my quadratic equation here.
Wait, I thought it was minus 4r.
I moved it to the other side.
Oh, yeah.
So that's why it becomes a minus 21 and a plus 4r. All right, now we can factor this. So what factors of 15 give you negative 8? R minus 5. Perfect. Negative 5 and negative 3. So I get r minus 5 and r minus 3. So r minus 5 equals 0. R minus 3 equals 0. So r is going to equal 5. And r is going to equal 3. All right. I'm just going to kind of slide it over. I don't want to take it away. All right. Are there any mistakes in the algebra there? Do we make any mistakes? No. Okay. I wish I could say that.
You laughed way too hard.
So we got 5, we got 3. So we go through, check them, and we'll look at this. So my first one, let's check. R is equal to 5. So I got 5 minus 6 is equal to the square root of 21 minus 4 times 5. I got negative 1 over here. So I can tell right there it's extraneous because I can't take the square root and get a negative number. Does that make sense? So you don't even have to do the right side. 2, if I check 3, I get 3 minus 6 is equal to square root of 21 minus 4 times 3. I got negative 3 equals something, so I know this is extraneous too.
So you have 2. Wow.
So my answer here is no solution. The 2 that I got worked out are both extraneous solutions. So therefore, there's not going to be an r that you can plug in that you will also subtract it from 6 that will work. So yes, you can have 0 extraneous solutions. You can have 1. You can have 2, as many as the index is, or the largest degree.
Would you ever get a mullet?
I've had a mullet.
Really? Do you have pictures of me from high school?
Not with me.
Not any fun, right?
All right, we got 2 more to go, and then I'll turn you loose. So here I got cubed roots. I'm going to zoom in on these since I don't have to check these because they're cubed roots. Oh, this one's a cubed root. So my index is the same. So I can cube both sides. The right side's already solved, so it's the left side. So the nice thing about this example is that when you cube both sides, the radicals go away. And then now you're down to a basic algebra 1 problem for you. So 1 equals 2x minus 5. Add 5, so 6 is equal to 2x. So x is equal to 3.
They only do the like check the experience for experience of this too.
If it's even. So even if it was 4, you would still check. Because anytime there's an even root, you cannot take the even root of something and get a negative solution.
Okay.
They have to be
if,
positive.
If you have 2 solutions that are both odd, would you do any, like, would you have to check?
If the index is odd, it has nothing to do with the solutions. It has everything to do with the little number. So this is a cube. So that has nothing, I don't have to check it. This one's a square. So I need to check it.
It's not if the solution's even.
Right. The solution has nothing to do with it. It's just the index. All right, the last one's got the 5th root, just to show you something different. It's odd, so I don't need to check it. So when I solve this, this left side's already solved, so I'm gonna raise both sides to the 5th power. And watch what happens here, just so you can see it. So 5x minus 2. The 2's on the outside, so it's gonna get the 5th power. And then that radical is going to go away. Do you see that? So this to the 5th power, you can do this if you want to. And you can split this up into 2. Everything's going to get the 5th power. Okay? So if there's a number on the outside and on the right side like this, and the left side you're raising it, make sure you get that outside number 2. So solving this, I got a 5x minus 2 equals 2 to the 5th. So 2, 4, 8, 16, 32. X minus 1. I have to distribute this. So 32. X minus 32. Now let's combine like terms. So minus 5x. Add 32. So that gives me a 30 is equal to 27x. Divide both sides by 27. So x equals 30 over 27, which is what, 10/9? So x is equal to 10/9. And we're good to go. All right. Just knock out the evens in for homework on your practice sheet. Oh, he's back. So, yeah, so evens and we'll be good to go. So take this, you got your evens. We'll call this evens. So if you got questions, let me know. I'll stay on. And that'll be it for